Good evening. There's been really exciting news from the spacecraft Galileo, which is on its way to Jupiter by a rather roundabout route. It's scheduled to reach Jupiter in 1995 and drop a probe into the Jovian clouds. But meanwhile, it's been in the belt of asteroids, or minor planets, between the paths of Mars and Jupiter, and it's sent back this picture of the asteroid Gaspra, a strange little world, no more than 10 miles long, rather like a potato in shape and pitted with craters. And that is the first close-range picture we've ever had of an asteroid. In fact, Galileo did take another picture too, but we probably won't get that transmitted until Galileo passes near the Earth again at the end of 1992. Some time to wait. But meanwhile, we have the Magellan space probe in orbit round Venus. Now, Venus is brilliantly visible in the morning sky now, and you can't mistake it. It is so brilliant. And the other morning, I made a drawing of it with my 15-inch telescope, and there it is, shaped like a half moon. And you can see one or two vague clouds there. And that is all. We can never actually see the surface of Venus. It's permanently hidden by the dense, cloudy atmosphere. So the only way we can map it is by means of radar. And we have now a superb radar computer graphic representation sent back from Magellan. There's the rotating globe, totally unlike the Earth. And now we're going to have a more close-range look at Artemis Corona, which is a huge plain over 1,600 miles across, and then go over some of the craters and over the highlands of Aphrodite. So here we go on a tour of Venus. And this must be exactly what you would see if it were possible to go through those clouds. There are some of the volcanic areas, the Great Plains, and there's the crater Mitchell. Now we're going high over the Aphrodite highland. There are more mountains, these huge troughs. There's the trough there, going round the Artemis Corona. Nothing like that anywhere in the solar system. And remember, the temperature down there is something like 1,000 degrees Fahrenheit. And in a moment, we'll be soaring high over Artemis Corona, a landscape that no one's ever actually going to see, and I'm sure no one's ever going to visit, but nevertheless is quite fascinating. And you know, it really is amazing that less than 40 years ago we knew nothing about Venus, and we even thought the surface might be entirely covered with water. But I'm sure that no one's ever going to go there. And now, on to our main theme this evening, light pollution. People often write to me and say, what's happened to the stars? Why can't I see the stars anymore? Why have they faded? And the answer, of course, is that the stars are exactly the same as they've always been, but our skies are not. Inefficient, glaring lighting has made the skies lighter, and there's a kind of sheen all over them. And if you live in a city, you'll be lucky to see the stars at all. A campaign for dark skies has been spearheaded by the British Astronomical Association. And recently, we held a meeting in northeast England, and our president, Dr. John Mason, took this photograph of Gateshead by night. And I think you'll see that the problem is there. That, as it was very late, I think it was early hours of the morning, in fact. Even in my home down in Selsey, where I'm surrounded by sea on three sides, I do have a certain amount of light pollution trouble. And in fact, in my garden, I've put up two screens to hide the street lamp from shining across one of my telescopes. It is everywhere. It's a global problem. Look, for example, at California. There is the dome of the 100-inch Mount Wilson telescope, so long the largest and best telescope in the entire world. And there's the 100-inch itself, the telescope used by Edwin Hubble to show that the universe is expanding. Now, that telescope has been put temporarily, we hope, out of action simply by the light pollution from Los Angeles. And there is the view from Mount Wilson. You can see there are two layers of smog as particles in the atmosphere are lit up by the artificial lights of Los Angeles. It is, in fact, a problem that affects the entire world. There is an international dark sky association. The president is an American, the American astronomer, Dr. David Crawford. He was over here recently, and I asked him, what was the main cause of the trouble?
Well, Patrick, the problem really is that we have so much bad lighting around, and so much of the new lighting that's going in has never seen any lighting design. Somebody just buys a light and hangs it up indiscriminately, and so light's going everywhere into our eyes to cause glare, but particularly for our cause, so much of it's going directly up into the sky, and that's what causes the urban sky glow. It can be bad street lighting, bad flood lighting, bad car lot lighting, bad home lighting, any of it. What we need is, of course, good lighting.
Well, so far as controlling this is concerned, what success have we had in America in dealing with the problem, and how have you gone about it?
Well, we've had a great deal of success in some areas, like Tucson, where I come from, because we've been working on it for quite some years. So that the skies in Tucson, even though it's a city of 700,000 people, we can see the Milky Way from the center of the town.
How have you achieved that?
Well, we've worked with the lighting engineers mainly and with the city officials. If you want to get solutions, you have to work with the people who can help you. And we look upon all these people as allies and helpers, not as enemies. They're doing all the lighting, and therefore there's where the key to success is.
What exactly should they be doing?
Well, they should be using quality lighting. And in fact, we are allies with the lighting industry. Yet I've spoken with lighting engineers here, and they're doing exactly the right things. They understand what good lighting is, and the thing that really is needed for success in America or here is just to get the good lighting in even faster.
Quite apart from the astronomical aspect, what are the benefits of better lighting?
Well, bad lighting is lighting that causes glare, and you can't see. Glare never helps visibility, and when you're driving down a motorway or a street and you're blinded by glare, that's dangerous. Good lighting doesn't have that, and that's the same kind of lighting that puts light up into the sky and gives us great bothers.
And you think in the long run that something really will be done about it?
Well, I'm very optimistic in the long run, because I've found that when I talk with people and educate and build up awareness about these issues, it's a game in which everybody wins, because we keep dark skies because we have better lighting, and we're not putting lighting up in the sky, wasting an astronomical amount of money. We see a lot better at night because we're using much better lighting, modern fixtures which control the light and don't waste it, don't cause glare. And we have a much more ambience environment at night. Things look nice, they're not cluttered. We have a much more appealing night, both because we can see the sky and because we have better lighting.
There are so many people who say to me, astronomers want to put out the lights, and of course that simply isn't true.
Absolutely wrong. What we want is people to use the light, not to waste it. If we put half the light that we're generating up into the sky, it doesn't do one bit of good for safety and security. We want good lighting, not too much, not too little. Astronomers are absolutely not saying turn off the lights. We're saying use good lighting, because the good lighting means that we have dark skies, we save a lot of money, and we can see better at night instead of being blinded by bad lighting.
It's a global problem. Look at this picture of the darkened Earth. Over on the left-hand side, the Americas. To the far right, Japan. Europe, just above the center. You can see there the tremendous amount of light pollution there is, particularly in the Low Countries. There's the United Kingdom. We can see it there. Over to the right-hand side, Holland and Belgium, very bad. France, rather better. But you can see the amount of light pollution there is all over the country. It's small wonder astronomers can't see very much. And, of course, it affects our observatories. Dr. Derek McNally is the director of the University of London Observatory at Mill Hill. And, of course, Derek, you're having your problems.
Indeed, Patrick, we're having our problems. As Dave Crawford rightly points out, the street lights are an enormous problem. You see the yellow glow of the A1, but you can also see something else which is affecting us, which are the lights caused by passing aircraft on their way down to Heathrow.
Actual light pollution is one thing. What about the problem of colour?
The problem of the colour of the lights is of paramount importance to us, particularly when we do spectroscopy. For example, we can show that white light is made up of light of very different colours by setting the light of a normal slide projector through a prism, and one sees that the white light is split into its component colours from red through yellow and green to blue and even violet, the colours of the rainbow. But not all lamps, fortunately, give that form of continuous spectrum. If you take a sodium lamp, which fortunately most street lighting is, low-pressure sodium, in the low-pressure sodium light you will get, in fact, two very narrow lines instead of the continuum. In the graphic you can see the sodium spectrum above the continuous spectrum, and so you see how much freedom there is to use the rest of the spectrum.
Yes, indeed.
And most astronomical spectroscopy is in any case done in the blue. So low-pressure sodium, which is the top light on this graphic, gives you a nice narrow line, and all the rest of the spectrum is free. High-pressure sodium takes up rather more of spectrum space and introduces light into the blue and into the red. But worst of all are mercury lights, which have spectrum lines all over the place and are a complete nuisance. And of course the new halide lamps, which are so beloved for sports grounds, tennis courts, outdoor facilities, which give a continuous spectrum again, and of course are an anathema to us.
Can you get around that with modern type equipment?
Oh, indeed you can. By using filters and high-speed modern charge-coupled device detectors of great sensitivity, one could go a long way to circumnavigate these problems.
Even so, it'd be better if the light pollution were not there. And of course, other types of equipment can also cause trouble for optical astronomers. What about radio masts? Look at these, which border the great Mount Wilson Observatory. They do no good at all. And of course, we've got to remember there's also radio pollution. After all, visible light is only a small part of the whole range of wavelengths or electromagnetic spectrum, and on the long wave or radio end, there's considerable trouble now.
Indeed, and unfortunately, the radio astronomers are as much beset with electromagnetic noise as the optical astronomers.
Even more so in a way, they can't really get away from it.
They cannot escape because of things like mobile phone transmissions, high-definition television, satellite communication, and of course we all do our little bit to contribute to their problem with our multitude of domestic appliances. One thinks of refrigerators, one thinks of TVs, one thinks even of domestic irons, and above all, we are continually switching on and off equipment and lights. Not only can you hear the click of the switch as we switch it off, but you can hear the radio noise that the switch generates, switching on and off.
You can indeed.
The feature that all of these switched items have in common is that whenever you flick a switch, you generate a little spark. And we have here a little spark generating machine which will generate a nice little spark for us between the two spheres, from the small to the large. And as that spark clicks through the air, it also generates a little pulse of radio waves, which we can also hear.
Do they have much trouble from this kind of thing at Jodrell Bank, where the great Lovell radio telescope is?
Yes, I'm sure they do. The farming community with their milking machines and other electrical apparatus do their best. The British Railways have an electrified line running close to Jodrell Bank, which you can see from your excellent picture. And this is another source of radio noise, but most of this can be filtered away.
What about the overall problem of general noise? I think it's known technically as white noise.
Yes, by and large, when you integrate over all our activities, all our turning off of lights, all of our refrigerators coming on, our electric irons cutting in and out, it all gives an integrated background of noise. And they're going now to try and dim me out in this program by bringing in a lot of noise, largely to annoy the viewer, to show them what it is like to have a signal which you're trying to hear and you cannot really make out because of the noise that is coming in over it. And we're going to do the same again with a pulsar signal from Jodrell Bank. The pulsar you can hear popping away, and then we are going to bring up the white noise to try and drown this out.
It certainly does so, most effectively.
I'm afraid it does.
Let's turn now to the problem of space pollution, and here we're dealing largely with particles. This is a picture of the Space Shuttle Discovery before launching that I took some time ago. Quite recently, while Discovery was in orbit round the Earth, it had to take evasive action to avoid a large piece of space junk heading in its direction. Now, luckily, that piece was large enough to be tracked by radar from Earth. But smaller particles can't possibly be tracked in that way, and it's amazing how much damage a very small particle will do. In fact, the shuttle window was damaged quite recently by a fleck of paint which happened to hit it. And do you remember the time when the Giotto space probe was going into Halley's Comet? 1986. How long ago that seems. Well, as it neared the comet with a lot of dust around, the shield was actually pitted. And then, as it went into the comet's coma, we started getting the pictures back. And they were going very nicely until, not long before it was due to make its closest approach to the nucleus, it suddenly stopped. We were getting the pictures back. That, of course, was a false color picture. And then, suddenly, nothing. And the reason for that is that, in fact, the probe was struck by a piece of material, grain of dust, rather smaller than a piece of rice. And that was enough to knock it off course. So it's quite amazing what a small piece will do. But, of course, when we come nearer the Earth, we are dealing with material we put up there ourselves. And when we look at a representation of near-Earth space pollution, it's quite horrendous.
It is quite frightening to think of how many satellites and bits of satellites and spent rocketry that happen to be floating around in low Earth orbit. This picture is quite horrifying in itself, but it does rather less than justice, since this refers only to the trackable pieces. Pieces less than 10 centimeters in diameter cannot be tracked.
And the geostationary pieces as well, of course.
And of course now the geostationary orbit is also getting rather full. This is the orbit that, for example, contains the spectroscopic satellite IUE.
And of course the Sky satellite.
And of course Sky satellite. Any of these is subject to possible bombardment by debris.
I think is really the near-Earth problem is the worst. Think about the Hubble Space Telescope, which may be faulty, but is sending back superb results. And I gather there's a 1% chance that in the 17 years planned lifetime, it will be hit by a piece of material large enough to do serious damage. And that's not really acceptable, is it? That's not really acceptable, because if that is the chance for an absolute catastrophe, the chances for minor damage are very much higher. And it's amazing how many satellites and pieces of material are up there now. And this is causing problems for optical astronomers too, because plates taken for quite different reasons are found to be trawling the satellite trails. Look at this one. There were 3 trails there. You can see them quite clearly. Yes, these beautiful plates, which are taken of a field 6 degrees by 6 degrees, are really works of modern art. And they take perhaps up to 2 hours to obtain. And in that time, you have a picture which is crossed by 3 satellite trails. Here's another example. This lovely picture of a spiral galaxy taken at the European Southern Observatory. And there, on the right-hand side, is a red line marking the trail of a passing satellite. Yes, this is a lovely colour picture done by taking 3 plates in different colours. And it was the red plate which suffered from a satellite trail. And satellite transmissions can themselves do damage, particularly in the shortwave or gamma ray end of the spectrum. Oh, indeed they can. The transmissions from satellites, and one thinks in particular of the GLONASS navigation satellites belonging to the Soviet Union, these are producing so much interference that they are almost destroying any possibility of detecting the interstellar molecule OH. And you can get spurious gamma ray bursts too. And indeed, you can get spurious gamma ray bursts. One looks for these burster objects in gamma rays in optical wavelengths, and sometimes you think you've got a gamma ray burst, and the more logical explanation is that a satellite has crossed your field of view. So we have all kinds of pollution: optical, radio, shortwave, space pollution. But of course the sky can never be really dark, and we do have natural phenomena. And of course there's the lovely zodiacal light, due to the thinly spread particles in the main plane of the solar system. Astronomers who like dark skies are not at all impressed with the full moon. That certainly causes light pollution. You can't do much about that. And of course the aurora borealis. We had a lovely display of northern lights not so long ago. And I think you'll agree that that's one piece of sky pollution that is really acceptable. Indeed, Patrick, I know how deeply you feel about the moon, but I think the aurora is really the beautiful face of pollution. It is. Meanwhile, there are various encouraging signs. I heard only yesterday that the Southampton City Council has recommended to Hampshire County Council that they should put all their new lights in the modern way, shining down, not up. And they've actually started this in an area of Southampton called the Avenue. There, the lights really do shine down. They cause a very nice, even glow on the ground, and they don't shine up at all. And this is a very encouraging first start. And do you think that other councils are going to follow Southampton's good example? I hope so, Patrick, and I also had some good news this week. Agreement has been reached with the Russians to reduce substantially the interference from GLONASS. Well, I think we're making progress, and in time, if all goes well, we should again be able to see the stars. Derek, thank you very much. Meanwhile, if you want the latest astronomical information, you can ring up the Sky at Night information line, 0898 666 000, or you can dial CFAX, page 616. When I come back next month, there's going to be a very interesting program. I'm sure you've heard of the discovery of this weird object, a planet revolving around a neutron star, made by astronomers at George Road Bank. Well, next month, Professor Andrew Lyne and his team are going to join me to give us the latest news about this extraordinary and very puzzling object. So until then, good night.